Now this is the problem that we just did. And before we called out his vertex to be what? Negative 2, comma 1. Now I'm going to show you that there's another way for you to find the vertex. And that's by completing the square. But completing the square gets kind of weird and kind of wonky because we're not looking at completing the square in an equation. You have to do it within an expression, so you have to make sure you correct for things. In an equation, what you do to one side, you do to the other, right? In an expression, you just have to make sure you undo that. So if you add 5, that changes the expression, unless you also do what? Subtract 5, right? If I add 5, tell you what, I've got some money, I think.
We're talking about an expression.
Here, tell you what, I've got some money. If I give you 5 and I take away 5, nothing changes, right?
Right.
Cool. And that's what you're going to do with an expression. No, you can't have my 5 because that's about all I got. What was that? You want to be talking about political correctness?
No, we're just having our own little conversation back here. Just
As always.
A and B.
included you in it every now and then when it's appropriate.
Here's how we complete the square. You know how to complete the square. You know that when we complete the square, we don't want to have this coefficient here, right? But since this is an expression, you cannot just make it dissolve or go away. What you can do, though, is you can factor that out, right? Factor out the 2, and you have x squared plus 4x. Now, here's what I want you to not do. Don't worry about the constant. Remember when you completed the square? You kept the constants separated from things, right? And I want to do that as well here. Close the parentheses. I can't just divide by 2 because I have an expression. If I divide by 2, it changes what it means. Is this what I have the same as the original?
Yes.
Yes. Now, your job right now is to turn this guy right here into something that kind of completes the square. Not kind of, but just flat out does. That means I want this to factor as something squared. So it's going to be x. Remember how we completed the square? What did we do?
X plus 2 squared.
Half of 4 is 2. What's 2 squared? If I put a plus 4 here, that changes the problem. So how do I correct for that?
Plus 4 on the other side.
I have to subtract 4. Remember I put the $5 bill and I took it right back? That's messed up. If I add 4 and take away 4, is that true? Is that still 0?
Yeah.
Have I changed anything? No. But here's what I did, though. Is x plus 2 quantity squared using all of this? When I factor to get x plus 2 quantity squared, was that because I used all of this? Does all of this factor to give you this? No. What factors to give you this is that part right there. So my question to you is, where does this negative 4 go? It only took this part right here. That part completes the square, right? And it factors to give you x plus 2 squared.
So then is it minus 4 plus 9?
You would think it's minus 4 plus 9, but notice that your minus 4 is stuck inside this guy,
Minus
right?
8 plus 9.
Right, so when you distribute the 2 to the 4, you get negative 8, and the plus 9 is already out there. So when you finish this guy,
But we can just use the other formula, right?
Yeah, it's still
but look what I did. I went from the quadratic function to something that was in that vertex form, right? Does this match up with your vertex being negative 2, positive 1?
Yep.
It does. So let me just recap what we did here. I completed this square by putting in a plus 4, right? But if I just put in a plus 4, that changes the problem unless I also take it away. Right? But do I need all of the stuff in the parentheses to give me my binomial square? Did I need all of that? Did I use it all? No. I only used what I have underlined here in green. The minus 4 is a part of that square. But he can't just come out here and play. Yeah, come out and play. So 2 times -4 is -8. That's how he comes outside. He's got to go through the bouncer first. You know what bouncers are, right? The people that don't let you into the clubs. Hate those guys.
Experience with them?
No. Me, experience with them? Nah, not at all. What if I showed you an easier way to do this, where you didn't have to complete the score? Would you be happy? You said the vertex equals -2, 1, right? Don't y'all agree? And we know that this is my H and K. From that vertex formula, it tells you how you move up, down, left, and right. What was the A in your original quadratic function? 2. You have all this stuff here. Do y'all agree with that? That's true. We found it out. Your form that I gave you was written like this: A times x minus h squared plus k. A lot of people freak out when they see this, but you have to remember, if you have numbers here, you guys are good to go. I'm just not putting the numbers there until now. What was your A? 2. X minus h. What's minus h if h is -2? Plus 2, and plus, what's k?
1.
There you go. It's the same thing. Now, how did I get this vertex to begin with, though?
With the vertex formula.
I used my vertex formula. What was the x coordinate for the vertex formula? How do you find that? Negative b over 2a. And why is negative b over 2a something that we can remember? Because it comes from that quadratic formula. You know the quadratic formula, so you know negative b over 2a. And if you know that x is negative b over 2a, how do you go about finding your y? You just plug it into your function, right?